Okay, so that's good. Yeah, Grant just said that it's the pattern 112439. We are talking about a parabola, right? Okay, so right here on question 1, describe what is a quadratic function? It's a U-shaped curve, right? A quadratic function is a parabola. What is the parent graph of a quadratic function? You guys remember we've done this before. The parent graph of a quadratic function is y equals x squared, right? And that pattern that Grant was talking about is right here. If you make an input-output table, you plug in 1, 1 squared is 1, plug in 2, 2 squared is 4, and this is the pattern to all parabolas that we could use. I mean, yeah, we'd have to modify the outputs at times, but this is the parent graph of all parabolas. So the word quadratic itself implies x squared. Again, the word quadratic implies x squared. All right, so for example, if I told you next week we're going to be solving quadratic equations, which we will be solving quadratic equations next week. Here's a quadratic equation, x squared equals 9, right? Why is that called a quadratic equation? Because there's an x squared involved, okay? So a quadratic function is just something like f of x equals x squared. That's a parent graph. But of course, it could be something like f of x, or you don't even have to write f of x. You could say y equals 2x squared minus 4x plus 8, right? That's a quadratic function as well. Any quadratic function will produce a U-shaped curve, and it all comes from the parent graph, some type of modification of the parent graph. All right, so let's move on to the next question. Jot that down. Write the standard form of a quadratic trinomial function. We learned this yesterday. If you forgot, talk to a partner, or maybe look at yesterday's notes to write down the standard form of a quadratic trinomial function. Again, the word quadratic simply implies that there's an x squared involved. Trinomial means that there's 3 terms that we need on the standard form. Hopefully you remember that from yesterday. Go for it. Talk to a partner. Guys, as I heard you guys talk, there's slight confusion. Some people are saying the Vertex formula. I'm not asking for the Vertex formula here. I'm asking for the standard form. Now remember, form is the way an equation is organized, right? The way an equation is organized. And of course, trinomial, that should be a hint that there's 3 things in this organization of the graph. So let's call on somebody. Thank you very much. So there's the answer. Y equals, or you could do f of x equals ax squared plus bx plus c. And we need to remember that the a, b, and c are just numbers, right? Out of a, b, and c, which one would you say is the most important number that will tell you a lot about the graph of a parabola? A, definitely. A, if it's positive, it opens up. A, if it's negative, it opens down. If it's closer to 0, it gets wider. If it's further away from 0, it gets narrower, right? So A tells you a lot. But anyways, A, B, and C are just numbers. We might as well jot down a little bit more here. What if the A value is 1? What could we use? It's like you could use the parent graph pattern, the 1, 1, 2, 4, 3, 9. So write this down. If A equals 1, you can use pattern 1, 1, 2, 4, 3, 9. And of course, if you had a different A value like 2, you could still use it, but you just have to change these outputs by multiplying them by 2. If you had a 5 right there, you'd have to change these outputs by multiplying them by 5. So that's good, knowing what a standard form quadratic trinomial function is. Ax squared plus bx plus c. You need to know this in order to find the vertex, because that's the only way you're going to be able to find the number that belongs in the formula itself. So let's go to that next question. What is the vertex formula for a standard form quadratic function? Okay, share with the partner. I'm going to call on somebody in a minute. Go for it. Thank you very much. X equals negative b over 2a. Now, since we're writing down in our notebooks here, what could you give to somebody that's barely doing this for the first time? What tip could you give them? It's the x value of your vertex, absolutely. But the tip, I would say, is use parentheses, right? So let's actually rewrite this right next to it. Write down minus parenthesis over 2 times parenthesis. So this is what you're going to write. Whenever you apply this formula, I want to see this always. That way you could identify your B value and just put it right in the parenthesis, identify your A value, put it right in the parenthesis. And again, this will only give you the X, you still need the Y. How do you find the Y if you already have the X? You just plug it in and do the math and you'll find it. All right, let's jump to the next question. This is more of a review of Algebra 1, right? What is an X-intercept? What is a Y-intercept? Talk to a partner. Okay, so the word intercept, what does it mean? When you say football interception, what does that really mean? That means that the ball is going towards a certain player from the quarterback. Let's say the pass is coming right here to this guy. Well, maybe not there. Let me go back. It probably looks like it's coming this way, right? And this other guy intercepts. It crosses the path of where it was supposed to go, right? It crosses the path. Or how about if somebody says, where's high school, Southwest High School located at? You would say the intersection of La Brucherie and Ocotillo, right? So the word intercept means where they cross. So what's the x-intercept? Where your graph will cross the x-axis. Cross or touch, that's right. So write that down. X-intercept is where your graph, now why do I say graph instead of line? Because it could be a parabola, could be a line, could be it could be a V-like graph if it's an absolute value function. So it's where your graph, doesn't matter what kind of graph it is, if it crosses the x-axis, that's your x-intercept. Same thing with the y-intercept, wherever it crosses the y-axis. So number 5, how do you find the x-intercept or y-intercept of any function? Again, this is from Algebra 1. To find the x-intercept, you have to do something. To find the y-intercept, you have to do something. Talk to a partner. Go for it. So check this out, guys. From Algebra 1, to find the x-intercept, you set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve. Okay? Now, if you don't remember that, let's actually look at some examples. Check this out. Let's just focus. What do you guys want to do? X-intercepts first or y-intercepts? X, okay, so could somebody tell me what that x-intercept is? 3, 0, right? How about this x-intercept? 4, 0. How about this x-intercept? 5, 0. How about this blue line? -6, 0. The red, the black line, -4, 0. This one right here, 0, 0. How about this yellow one? 2, 0. How about this red one? 4, 0. How about this green one? 6, 0. What do you notice about every single one of those x-intercepts? They all have the y value of 0. Okay? So that's a fact, guys. No matter where your line crosses, or wherever your graph crosses the x-axis, your y value is going to be 0. Your y value is going to be 0. Y value 0, y value 0. So that's a fact. So whenever you want to find the x-intercept, you take what you know to find what you don't know. So what do you know? The y value has to be 0. So that's exactly why to find the x-intercept, we have to set y equal to 0 and solve. And to find the y-intercept, the same thing with the y-intercept. When you look at your y-intercept values, see that one's 0, 6. This y-intercept is 0, -3. If you look at all these, what's the y-intercept there? 0, 8. Right there, 0, 4. Right there, 0, 2. Right there, 0, 0. Right there, 0, -4. Right there, 0, 6. On the y-intercepts, all of your x values are going to be 0. That's a fact. So this is where the rule came from. I don't want you to just memorize it. I want you to understand it, right? So the rule is to find the x-intercept, you set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve. Now, why do we need to know this? Because you're not always going to be able to see the graph. So let's zoom into this guy, and let's pretend we don't see that graph. And if I tell you, find the x-intercept, well, you're going to have to set y equal to 0 and solve. So this is really the equation 2x plus 0 equals 6. So that's really just 2x equals 6, which means x equals 3. I just found my x-intercept. This line, whatever it is, I haven't even looked at it. I mean, we saw it earlier, but this line will cross the x-axis at 3. The y-intercept, we're going to find that by setting x equal to 0. So the equation is 2 times 0. You're going to put an x right there because you're setting x equal to 0. Plus y equals 6. And you end up with 2 times 0, that's nothing, so y equals 6. So I know that my line, even though I'm not looking at it right now, I know that my line will cross the x-axis at 3 and the y-axis at 6.
Just plug in 3 into x.
Okay, so let's take a look at these problems. I would like to, in your notebooks, please jot down all of these directions right here. I want you to state the following of each quadratic function. Number 1, I want you to find the vertex. Number 2, I want you to tell me the actual maximum or minimum value. Number 3, find the axis of symmetry. Number 4, state your y-intercept. Number 5, state the domain and range. And I want you to state all of this without looking at the parabola, without looking at the graph, just using algebra. Okay, so first of all, let's jot this down as the instructions of what we're going to be doing. And then I'll actually provide you these 4 questions right here, okay? So first right now, just jot down the instructions in your notebook on a blank page. You're going to have to do all this work in your notebook. I want to pause it. So the little slip of paper that I gave you doesn't have much space. You might want to copy down question 1 over in your notebook. That way you could have as much space as you need, okay? And I'm going to go thoroughly through this. I expect you guys to show as much work as possible. A lot of students try to do this work in their head. That's where mistakes happen. All right. So let's first begin with what they're asking for, the vertex, the most important point of a parabola. Even if you were graphing, you would start with the vertex. So let's find that vertex. It is a standard form quadratic trinomial equation. We're going to begin with the formula itself. X equals negative b over 2 times a. Now, I always write down the formula even though I already have it memorized. Next thing I do is write down the formula again, but instead of the b and the a, I put parentheses. I highly recommend this for you guys to do. Then after that, of course, I identify my a value is 3, my b value is negative 6, my c value I don't even care about because it's not involved in the formula. So I plug in the b value of negative 6 right up here. I plug in the a value of 3 right down here. And up on top, a minus negative 6, that becomes a positive 6. So I already have 6 up here, and 2 times 3 is 6 down here. So 6 over 6, that really becomes 1. What did I just find right here with this formula? The x, right? The formula says x equals, I just found my x value of my vertex. So my first thing is my vertex, and so far, my x value is 1. That's my x value. I still need my y. So to find my y value, I plug in x equals 1 into the equation. So again, here's my equation. I'm going to rewrite it exactly the way it is, but instead of x's, I'm going to put parentheses because x is 1, and I need to put that 1 value right into both of those x positions because I know that x equals 1. So I put a 1 here and a 1 there. Let me rewrite this, but with parentheses instead of x's. Do the same, please. Y equals 3x squared minus 6x minus 4. Of course, we are plugging in 1 into those parentheses. Now it's a question of doing the math correctly with the correct order of operations. PEMDAS exponents will be the first thing that you tackle. 1 squared is 1. And of course, you have the times 3 right in front. Let me rewrite everything so we don't make mistakes. 6 times 1 minus 4. So I now continue with 3 times 1, that is 3. 6 times 1, that's 6 with the minus sign in front. Bring down the minus 4. 3 take away 6 is negative 3. Negative 3 minus 4 is negative 7. What did I just find here? The y value. And that's barely the first thing that they asked for the vertex. So ladies and gentlemen, we have the answer to number 1. They asked for the vertex. There it is. That's the most important point. 1 comma negative 7. If you were graphing, you would now plot that point and also draw your axis of symmetry. But we're not graphing. What do they ask next? They say, is this a maximum or minimum value, and what would the maximum or minimum value be? So in order to answer this, you need to know that the a value is positive, which means that this opens up or down? Up. So, and we also know that the a value of 3, it's a little bit further away from 0, so it's going to look something like this. It's going to be kind of narrower than usual, right? Which means that this has a maximum value or a minimum value? Minimum, right? Minimum down here, minimum down there. So the question is, where is down here?
Negative 7.
negative 7, right? So for the minimum value, you could say, so number 2, is it a max or is it a min? It's a min. And you could say just that y value, negative 7. That's 100% correct. Or if you wanted to, you could restate the vertex 1, negative 7. Either one's totally fine. Either one's 100%. The minimum value, or you could say minimum value is the vertex itself. Any questions so far? No? Moving on to question 3, axis of symmetry. Well, remember, if we were graphing, you would graph your vertex, and then the next thing you do, what I would do on the videos is draw a green dotted line right through that vertex, and the equation of that green dotted line would be x equals the x value of your vertex. So what's the x value of my vertex? 1. So here's my axis of symmetry equation. Axis of symmetry equation. You need x equals right in front of the x value of a vertex. That's the only way it's going to be a vertical line. If you just say 1, that's just a number. But x equals 1 produces the vertical line that'll actually provide a reflection on your parabola that crosses right through the vertex. Okay, what else do we need? We need a y-intercept. So how do we find the y-intercept? Anybody? We just said it. It's where your line crosses the y-axis, right? Where your parabola, but see, we don't have a graph. We can't see it.
Oh, do a 0 on the x.
Exactly, right? Algebraically, right? How do you find the y-intercept? You set x equal to 0. And ladies and gentlemen, that's the easiest thing to do. Because when you plug in 0 for x right here and a 0 for x right there, it's going to end up being 0, take away 0, which is 0, and your c value will be your answer. So for the y-intercept, that's like a free point right there. The y-intercept is negative 4, the c value. Now, of course, you could give me it as a coordinate. So this is 100% correct. Or you could have given it to me as a coordinate like 0, negative 4. That's the location of where it would cross the y-axis. How about domain and range? Number 5. Domain, x equals all real numbers. That's on all parabolas. How about the range? The range, y is, it's either above or below that minimum value. So it's greater than or equal to negative 7. How do we know it's greater than? Because it's positive, which means it's opening up. The minimum value we said was negative 7. So the whole parabola has to be at negative 7 or above negative 7. So that's y is greater than or equal to negative 7. And that's about it, guys. We stated so much about a parabola without even looking at a parabola, just using algebra. So I did one example. I want you guys to do the rest. So the very first thing to do, they're asking us to find the vertex. And obviously we need the vertex formula. And the vertex formula is x equals negative b over 2 times a. So please write down that formula. And you're probably going to want to write this in your notebook, not on that little piece of paper itself. I would also put equals and then do this formula over again, but instead of b, put parentheses, and instead of a, put parentheses. Then after that, I would most definitely identify that my a value is 2, my b value is 16, and my c value is 1. Okay? So the b value is 16, put that 16 inside of the parentheses. The a value is 2, put that 2 right in the parentheses. So up on top, I really have a negative 16, and on the bottom, I really have a 4. So what's my x value really? It's really a negative 4. I hope everybody's with me. And again, this is called the vertex formula. And this formula only gives us the x value. Okay, it only gives us the x value of our vertex. So if you wanted to, your first answer, you could put v because we want to give the vertex as our answer. And the very first thing of this vertex, or the very first bit of information, is that the x value is negative 4. Now we still need the y value. How do I find the y value when I already have my x? Plug it in, right? Plug in. What am I going to plug in? I'm going to plug in x equals negative 4 to find y. Okay, so I'm going to plug in x equals negative 4 into the original. So here are my x's, but the thing is I already know that x equals negative 4. So I'm going to put a negative 4 in both of these x's in parentheses. So I'm going to start by rewriting the whole thing and putting parentheses instead of x's. Y equals 2 parentheses squared plus 16 parentheses plus 1. And we said we are plugging in the x value of negative 4 wherever those x values were at. Now, a lot of students get lazy and they try to do this in their head. This is where mistakes happen, right? Don't get lazy. Write it all out. Do the parentheses situation thing and then start simplifying. with the correct order of operations. There's nothing to do in the parentheses, but we do have exponents. So when I go negative 4 squared, what do I get?
16.
Positive 16, right? So what I really have, let me rewrite it. 2 times 16, and I'm going to rewrite the rest. Plus 16 times negative 4 plus 1. Okay, so I did exponents, and now I'm going to multiply. What's 2 times 16? 32. Okay, 32. And then how about 16 times negative 4? Maybe with the calculator, we'll get a negative 64. And then bring down the plus 1 at the very end. And now it's just a matter of adding and subtracting. And of course, you could use a calculator right there. 32, take away 64, that's negative 32. And negative 32 plus 1 is? Negative 31. What did we just find here, guys? The y value of our vertex, right? It says y equals, and we found out that it equals negative 31. So negative 31. If I were graphing, I'd have to find this vertex and I would graph this vertex. I would not be happy graphing this vertex because this is way off a 10 by 10 graph, right? Negative 4, negative 31. Anyways, let's move on to question 2. This was a hard part. The rest is cake. Question 2, do we have a maximum value or minimum value?
Min.
It all depends if it opens up or down, right? Now, does a parabola open up or down? Opens up, okay? So if we know that it opens up, let me just sketch a parabola that opens up like that. It is kind of narrow because the a value is further away from 0 than 1. So that's like a vertical stretch if we wanted to review transformations. But nevertheless, it opens up, which means that it's going down, then it reaches a minimum value, then it comes back up. So depending on if it opens up or down, that's how you know if you have a maximum value or a minimum value, right? Now, we already know that that minimum value is what coordinate? What's the coordinate of this guy? It's a vertex, negative 4, negative 31. So for the answer on number 2, you could say that it's a minimum value, and you could just give the y value, which is negative 31, or you could actually give the entire vertex again if you wanted to. But most of the time, when they refer to the max or min, they just give the y value, okay? So it's kind of like if I were to say, hey, a guy is throwing a ball up in the air and it reaches a maximum height and then it goes back down, you would just say, what's that maximum height? You wouldn't give me a coordinate, you would just say the y value, right? How high it went. But you could, if you wanted to, they're both perfectly fine, perfectly correct answers, giving me the minimum as just the y value or giving me the vertex over again as a minimum value. Okay, so let's move on. We already stated the vertex. We stated that this was a minimum value, and that minimum value was negative 31, which is technically the y value of our vertex. How about the axis of symmetry? Yeah, it's that green dotted line that we draw right through the vertex, but we don't even have a graph. That's not even a real graph. Yeah, we need to remember to find the axis of symmetry, we always say x equals the x value of your vertex, which in this case happens to be negative 4. That's your equation. If you just say negative 4, that's not good enough, because you need to have the x equals in order to produce that vertical line right through the x-axis at negative 4. How about number 4? What's the y-intercept? So where would the parabola cross the y-axis? Now that's a problem because you can't visually see it, but if you know the algebra, how do you find the y-intercept? Well, you set x equal to 0 and solve, right? So if I set x equal to 0, it's the easiest thing in the world because put a 0 here and a 0 there, your answer will be the c value 1. That's always the case. So this is the easiest math that you could do in this section, finding the y-intercept. How do you find the y-intercept? You set x's, these x's, you set them equal to 0 and solve. 0 squared is 0, 2 times 0 is 0, 16 times 0 is 0, 0 plus 0 equals 0, and 0 plus 1 is 1. So the c value will always be your y-intercept value. So let's write that down as answer number 4. Let me see, number 4, the y-intercept. You could give the coordinate 0, 1, or you could just say 1. You could also give the coordinate 0, 1. It's up to you. What else? The domain and range. Well, the domain on any parabola will always be what? That's right. So number 5, the domain, x equals all real numbers. It doesn't matter if it opens up or down, if it's wide or narrow. It's always going to go to the left and to the right forever. Now the range, we know that the parabola either goes up or it goes down depending on your a value. And so it can't be y equals all real numbers. So what are we going to say? Y is what? Greater than or equal to that minimum value of the parabola. So y is greater than or equal to what? Negative 31. Y is greater than or equal to that minimum value of the parabola. So again, if your parabola is opening up and it reaches that minimum value of negative 31, then it goes back up, you know that it's at negative 31 and above negative 31. So y is at negative 31 or above negative 31. Y is greater than or equal to negative 31. So ladies and gentlemen, we have stated 5 different things of this parabola, even though we didn't even take a look at the parabola. It's all based on algebra. So I want you guys to work on the other questions left, and that'll be your homework. You should finish in class before leaving. Of course, I'll probably explain the other ones with other classes. Number 3, we want to find the vertex first, okay? So again, for the vertex, you need the vertex formula. X equals negative b over 2 times a. Please write this down in your notebook, not on that little sheet of paper. You might run out of space if you try to do it on the little sheet of paper. So anyways, whenever I use this formula, first I have to memorize it. Now when I use it, I always write equals and I rewrite the formula, but instead of b and a, I put parentheses. So instead of negative b, I put negative parentheses. Instead of 2 times a, I put 2 times parentheses. Then of course I identify my a value is negative 1, my b value is negative 10, and my c value, it's not even in the formula, so I don't really care about my negative 4 as my c value. But anyway, my b value is negative 10, plug that in into the parentheses. My a value is negative 1, put that into the parentheses. And up on the numerator, the minus minus becomes plus plus. So I end up with positive 10 over negative 2, because 2 times negative 1 is negative 2. So what is my x value here? It's negative 5. What did I just find? I found my x value of my vertex, right? This right here is called the vertex formula, and it gives you the x value of your vertex. So maybe over here on the side, let's put down number 1, what they're asking for, actually up there, it says vertex. So my vertex is a coordinate which has the x value of negative 5. Now I still need my y value, so how do I do that? How do I find my y value once I already have my x value? Plug it in. Plug what in? Plug in the x equals negative 5 into the x's. So we're going to take this quadratic equation that's in standard form, and we're going to rewrite it, but instead of x's, I'm going to put parentheses. And that way I could plug in my x value of negative 5, which I found from my formula, plug it right into both of these x's, and I'll be able to find my y value. So plug it in. Plug what in? Plug in the negative 5 for x. So let's rewrite it first. It says y equals negative x squared minus 10 times x minus 4. And of course, we are plugging in that negative 5 that x really equals. Now we're going to do the math. If you want, carefully type this in exactly the way it is into the calculator. Exactly the way it is. I'm talking use the parenthesis button, use the exponent, everything exactly the way it is, and it should give you the answer. But I prefer to actually work through a piece at a time. And the first thing to do, besides parentheses, because there's nothing to do inside of the parentheses, we just plugged in the values. First thing to do is exponent. So ladies and gentlemen, if I did go negative 5 squared, what's negative 5 times negative 5? Positive 25. But there's a minus sign out here in the front, so you have to bring down that minus sign, and that really becomes a negative 25 again. Okay? So that's the first thing. Now rewrite everything so you don't make a mistake. Bring down the minus 10, the times negative 5, and the minus 4. Okay, so what else do we do next? Well, we now, after exponents, we have multiplication right here. So let's multiply negative 10 times negative 5. What's negative 10 times negative 5? Positive 50. So let's make some space here. We have negative 25 with the positive 50 with the minus 4. So then from left to right, negative 25 plus 50, that's just 25. And 25 take away 4 is 21. What did I just find now? My y value. See, it says y value is 21. My y value of my vertex is 21. So up here, we're going to put a 21 right in here. So there's my vertex. I'm glad I'm not graphing this. If I was graphing it, my first step would be to find the vertex and graph it. But this is going to be way off a 10 by 10 graph. So anyway, we move on to the second thing they asked for. Do we have a maximum or minimum value? Well, the question is, does this parabola open down, which would give you a maximum, or does it open up, which would give you a minimum? It opens down. The a value is negative. So imagine a parabola that opens down. That would look something like this, right? Oh, that is disgusting. I'm sorry. But anyway, think about if you throw a ball up in the air, it goes up, 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 and then it reaches a maximum height, and then it comes back down. That'll be the path of a parabola. So this is a maximum value, and we know that because it's opening down because the a value is negative. So for number 2, we could all write down number 2, we're going to put max. And what is the maximum value? If you throw a ball up in the air, it's this point right here, the maximum height. You could give that as a location on the XY plane, which would be the exact vertex all over again. Or you could just tell me what the height is, which would imply the Y value of the vertex. So what's the maximum height? Even though we don't have the graph, we know that this is the maximum height. So you could rewrite the whole thing, or you could just say the Y value, which is 21. So the maximum value, you could say, is 21. Again, you could say, or you could rewrite the vertex. I want to put this in a little cloud right here, because you could write that also as an answer. But most of the time, they just say, what's the max value? Oh, it's 21. Why is that? Because your Y value of your vertex is 21. Okay? If you throw the ball up in the air, it reaches a height of 21 feet, or whatever you want to call it, right? Anyway, moving on to number 3. What is the axis of symmetry? You guys remember when I graphed it, it would always be, like let's say this was my vertex. I would always draw a green dotted line that would cut the parabola perfectly in half right through the vertex, the axis of symmetry. And we would always say you write the axis of symmetry as x equals the x value of your vertex. So in this case, 3, the axis A of s is x equals what? -5, the x value of our vertex, which is up here, -5. So this is another answer. Number 4, the y-intercept. Okay, so the y-intercept, number 4, the y-intercept is where your graph will cross the y-axis. Now, we don't even have the graph. You're not able to look at it. So we don't want to do this visually. We want to do this algebraically. Now, remember, we just said to find the y-intercept, you have to set x equal to 0 and solve, right? And that's the easiest thing in the world when you have a quadratic trinomial that's in standard form. Because when you set these x's equal to 0, what's going to be your answer? The c value, which is -4. So it's as easy as that. What's the y-intercept? The y-intercept is -4. It's going to cross your y-axis at -4. This parabola that opens down, it's going to cross your y-axis at -4. And the last thing, number 5, says state the domain and the range. All right, so the domain is going to be x equals all real numbers. That's always true. Doesn't matter what kind of parabola you have, whether it's wide or narrow, opening up or down. It's always x equals all real numbers. Now the range is a different story. You're talking about your y values there. Now since this parabola does open down, that means that it does reach a maximum height and then it's back down. So here's your maximum height, and the whole thing is below or at that maximum height value. So we're going to say that the range is y is less than or equal to the y value of our vertex, that maximum value of our vertex, which is 21. So this was number 5. So we've stated 5 different things about this parabola that we haven't even seen. We just were able to look at the information based on the a value, and we used the formula to find the vertex, and we were able to state all these wonderful things about a parabola without even graphing it, or without even looking at the graph. All right, so I want you guys to try the other ones. I will have the video uploaded with all the questions explained. I'll explain the last question in my last class. Number 4. So I did explain the previous ones in different classes. So if you need help on the other ones, watch the video. But anyway, the first thing to do is to find the vertex. Okay, so the vertex is going to be a coordinate, right? But in order for us to find the vertex, we need to know the vertex formula. And the vertex formula is x equals -b over 2 times a. And you probably want to write this in your notebook over again. On that little slip of paper, it's not enough space, right? Whenever you do that formula, I recommend for you to rewrite your formula, but with parentheses instead of your b and your a value. And then after that, of course, you want to identify the a value is -1, the b value is 6, and the c value is 2. We don't even care about c. It's not even in the formula, right? So the b value is 6. Plug in the 6 right in there. The a value is -1. Plug in the a value of -1 right in there. And of course, let's do the math here. Up on top, we have negative 6. So I'm just going to rewrite it, negative 6. On the bottom, 2 times negative 1 is negative 2. And then we finally have negative 6 up on top divided by negative 2 on the bottom. That's really a positive 3. Is everybody with me? Good. What did I just find? The x value, right? This vertex formula, as you could see, it says x equals, it doesn't say x and y, it just says x. So far we've just found the x value of our vertex, which happens to be 3. Now, whenever you have the x value and you want the y value, what do? Plug it in, right? So what I'm going to do is rewrite this entire standard form quadratic function. I'm going to rewrite it, but instead of x's, I'm going to put parentheses. That way I could actually plug in my x value of 3, right? So let me rewrite it. It's going to be y equals negative x squared plus 6x plus 2. And of course, x really equaled 3. That's what we got from the formula. So let's plug in that value of 3 into each of those. Now, if you type this in exactly the way it looks on a calculator, I'm talking about with the parenthesis button, with the exponent button, if you type it in exactly the way it is on your calculator, it should give you the final y value, okay? But I like working things out. Parentheses first, but there's nothing to do inside of the parentheses. There's only 3's. Exponents next, so I'm going to go 3 squared. 3 squared is 9, but of course there's a minus sign right in front. I might as well multiply the 6 times 3 right here. 6 times 3 is 18, so plus 18 comes down. The plus 2 is also there. And from left to right, negative 9 plus 18, that's simply a positive 9. And 9 plus 2 equals what? 11. What did we just find here? The y value of our vertex, right? So right here, the y equals 11. So the y value of our vertex is 11. Ladies and gentlemen, we have done the most difficult part of this homework, finding the vertex. Again, we used the vertex formula, found x, we plugged in x to find y, okay? Second thing they ask is max or min value. See, the rest is easy, but you need to know what the different parts of this function represent. So first of all, the a value is negative. What does that mean if the a value is negative? What could you tell me about the graph of the parabola? It's going to open down, right? So if you were to just sketch a parabola that opens down, right, like that, that's ugly, but that it's opening down, which means from left to right, it's like if you threw a ball up in the air and then it reaches a maximum height and then it comes back down, right? So that tells you if it's going to be a maximum value or a minimum value. Obviously, if it were opening up, then you would have a minimum value down here. But it's opening down, which means you have a maximum value. So question 2, state max or min, and actually give me that max or min value. So write down number 2 somewhere. Let me write it, I guess, right next to the vertex one. Do we have a maximum or minimum? Maximum, because it's opening down, so you're going to put max. You could actually write out the word maximum value. And what is the maximum height of this parabola? What is the maximum height of the parabola? Now remember, your vertex is your maximum or minimum value. So you could, if you wanted to, rewrite the entire vertex and say, oh, my maximum value is 3, 11. That's totally fine. But most of the time, especially on multiple choice tests, they're going to just give you the y value of your vertex to be the maximum height, right? Because if you like throw up a ball up in the air, you're not going to give x and y coordinates. You're just going to say, what's that max height? Oh, that's the y value of wherever it reaches, right? So that max value is what, according to the information we have right here? 11. So the max value is 11. So there's the answer for number 2. Again, how do you determine if it's max or min? Look at the a value. If it's positive, it's opening up, which would mean you have a min value. If it's negative, it's opening down, which means you have a max value, okay? And of course, that maximum or minimum is simply the y value of your vertex, or you could even rewrite the whole vertex as your max or min. Moving on, number 3, what's the axis of symmetry? If you guys remember, the axis of symmetry, if you have a parabola, I always draw it as a green dotted line, cutting that parabola in half right through the vertex. But we always said that green dotted line is the equation x equals, and I always say write the x value of your vertex. So for number 3, the axis of symmetry equation is x equals what? 3. And that's it for number 3. Moving on to number 4. I know it's getting ugly, writing them all over the place. Number 4, what's the y-intercept? Now, we've already discussed that to find the y-intercept, you do what? Set x equal to 0. To find the x-intercept, you set y equal to 0, right? So what are they asking for? They're asking for the y-intercept. So we're going to say y-int. We're going to set x equal to 0, and that's the easiest thing to do, especially when you have a quadratic trinomial equation, because if you put these x's equal to 0, everything's going to become 0 except for the c value, and the c value will be your answer. So for the y-intercept, the c value is your answer. So the y-intercept is 2. The y-intercept is 2. And last but not least, we want our domain and range. So number 5, the domain, x equals all real numbers. Doesn't matter what kind of parabola you have, if it's wide, if it's narrow, if it's opening up or down, it's always going to go to the left and to the right forever. Okay, and what about the range? That one's an interesting one. Y is what? It's either greater than or equal to or less than or equal to.
It's less than.
Less than or equal to that max value 11, right? Less than or equal to that y value of the vertex 11. This is your answer for number 5. Now, how do I know it's less than? Once again, if our a value is negative, that must mean that it opens down. And if you're at the vertex, the highest point at 11, so it's at 11 or below, right? So that's why it's less than or equal to 11. So that's number 4. You guys could do the rest. If you need help on the rest, the video will be uploaded explaining every one of these, okay? And by the way, the answers to the vertex, because that's the hard part. Finding the vertex is the challenging part. Everything else is easy. Everything else comes from the vertex, right? The vertex answers are on the wall if you want to take a picture of them.